In this video, we'll take a look at how to run the nearest neighbor algorithm, which is an algorithm for finding a low-cost Hamilton cycle. And just to remind you, a Hamilton cycle is a cycle in a graph that contains all the vertices. So you want to start and stop at the same place, and you want to cover every vertex. So I mentioned that it helps find a low-cost Hamilton cycle because it may not find the lowest cost, but it will find hopefully a low-cost cycle. So here's the algorithm itself. It has 3 steps. You have to select a starting point that's a vertex, so you got to pick a vertex to start at, and then at each step you're going to add an edge by moving to the next vertex. But the way you decide what is the next vertex is by going with the cheapest available edge. And then you just keep repeating this until you come back to the beginning. So we'll run this algorithm on an example graph, which we have right here. We need to pick a starting point. Typically this will be given to you. We're just going to pick one, so let's start here. This has to be something that's given as input for the algorithm. So the algorithm says after you've selected the starting point, you want to move to the nearest unvisited vertex, and nearest means smallest cost. So this is our active vertex. At this vertex, we want to look at the costs of all the potential edges. So we could go with 12, 13, 9, this one's 15, and 14. And we need to pick the smallest cost out of those, which is 9, which means this edge is the one that we add. And so now this is our active vertex down here. So that's kind of one step of the algorithm. And now we'll repeat that step. So we're at our active vertex, and we'll examine the costs. I don't want to cross an edge twice, so that one's out of the question. I have 46, 7, 7, and 10. And when I come to a tie, we just have to find a way to break that tie. We can break a tie by just randomly picking one, but often the vertices will have labels on them, like maybe A, B, C, D, E, and you could just pick the one with the smallest label. But in this case, we just have to pick one, so let's take this 7. And that's now our active vertex. So we do the same thing. We have 5 as a possibility. We could go 11, 17. I can't choose this 14 because that would create a smaller cycle. And I don't want a cycle that has length less than 6 because that's the number of vertices. So I can't pick the 14, so I need to go 5, 11, or 17. So I have to go 5. And now this is the active vertex, so I can't choose 15. Basically, you can't go back to an already visited vertex. So my options are 21 or 12. So I need to take the 12. And here I only have one choice. I have to take this 25 because everywhere else has already been visited. And then finally, I need to go back to the beginning and take this 12. So notice this is a cycle, and it's a Hamilton cycle, because you can go here at your starting point, and if you follow the edges that you picked, then you visit every vertex. So the cycle that we get is a Hamilton cycle with weight, the sum of all the weights on the edges. So we have 9 plus 7 plus 5 plus 12 plus 25 plus 12. And if you add these up, this is what's called the total cost. The total cost of the cycle. And this is supposed to be a relatively low cost, although remember, as I mentioned before, the nearest neighbor algorithm doesn't guarantee that it will produce a smallest cost cycle. It's just a way of finding one that we hope is low cost. So that's how you run nearest neighbor.